with your neighbor. Any ideas or you can answer the neighbor, discuss his ideas. Both of you can answer something on the clicker, if you have a clicker, just to see that it is working. And will be, for now we have 28, 29 registered answers, which 20 are the correct one. So the correct answer is, by the way, I have here a kind of live graph of like who voted what. And yes, now we have 41 registered clickers. So probably most of them are working. Okay, so correct answer is D. And let me explain how it works. So this line, first of all, we talk about perpendicular lines. It's better to figure out what the slope is. And for this line, the slope is, well, not quite 2. We have to bring it first to standard form. So we first write it as minus 2x plus 5 is the equation of the original line. This line has slope -2. So the slope of any perpendicular line is, we go to this fact, so it's -1 divided by the slope of that line, -2, so it's 1/2. And finally, it passes through this point, 1, 2. So the equation we are looking for is, now we recall how to write an equation of the line that passes through the point and has a given slope. So the difference in y values, y minus 2, is proportional to the difference of x values, x minus 1, and the coefficient of proportionality is the slope, 1/2. So the rise is the slope times 1. Alright, so it looks like the system is working. Your answers, they will be registered, but they won't be used for any kind of purpose of like grading or anything. It's just for you to participate in the class. We'll generally try to start with some classes with a question like this, something short, something simple about the material of previous lecture, just for you to have a connection with the previous lecture. Okay, so let's switch to somewhat different material. Let's talk about how to find an area of different figures in the plane. So I'll start with some very simple figures. So we'll talk about some areas. One very simple figure is just like this. A square with side A. So all these angles are 90 degrees. And the area is just A squared. That's really simple. You can subdivide this square to A squared squares length 1, so 1 by 1 small squares, and well, area of each small one is 1, and there are a squared windows. So this one is the simplest one. Another simple one is an area of a right triangle, or well, first a rectangle. Besides AB, well, area is AB for quite a similar reason. We can subdivide this side to A parts, this side to B parts. You get A times B small squares, and the total area is A times B. Slightly more difficult one is the area of a right triangle. We'll start with the right triangle. So for this one, the area is AB times AB divided by 2. Let me explain why. It's also very simple. The thing is, the area of such a triangle is 1/2 of the area of the corresponding rectangle. So this is the same as this. So the area of each one of the halves is A times B divided by 2. So this is just very simple things. Now I want to discuss a slightly harder question. I'll draw for you a kind of graph paper. And on this paper I'll draw a square. So first side is like this. I go 1 unit to the right, 2 units down, then 2 units to the right, 1 unit up. Now we know that this angle is 90 degrees. Then 1 unit to the left, 2 units up, and close the square. So you can check that all these angles are 90 degrees. And the question is, what is the area of this square? So the question is, what is the area? So please, any suggestions? How can you find it? Yeah.
Usually right on the run. So you know, you go to the Pythagoras theorem to find the length of the side. So the goes 1 up, or on the bottom right-hand corner goes 1 up, and to the right, you do 1 squared plus 2 squared equals c squared, the length of the side of the square.
Okay. Yeah. So the idea was, we see that it is a square, and for a square we know what the area is. It's the side square. So if we can figure out what the length is, let me call it c, then we figure out that the area is in fact c squared. Okay, it's good, but well, I don't want at this point to use Pythagoras theorem. The reason is I have a simpler way to figure out what this area is. So it's a very good idea. We'll use it maybe in 5 minutes. Now I want to figure out what the area is without computing this distance.
Well, it's just like 4 triangles, basically.
Yes.
So
Let me draw a picture. I'm not sure that this is the exact picture that you had in mind, but I'll do it like this. I'll subdivide this picture to several much simpler ones. So here are 4 triangles, and there is a small square left. I'm using these triangles because, well, they are right angle triangles, obviously right angle triangles. So let me use some colored chalks. So here are my parts. 1 triangle, another triangle, another triangle, another triangle, and a small square. Now I can quite easily find the areas of each one of these parts. I have 4 triangles which are basically the same one but rotated 90 degrees 4 times, and a small square. So area is, the area of this triangle is what? 1 times 2 divided by 2. I'm just using this simple formula. 1 times 2 divided by 2. Well, I have 4 such triangles. So it's the area of this triangle multiplied by 4 plus another thing, 1 square. So the area of this small square. Okay, so the total area is 5. What's good about this calculation? Well, I didn't use anything complicated. Just this very simple fact and that very simple fact. No complicated theorems. Another beautiful fact, I now have a way to figure out what this length is without using any theorems, which you might have heard or might not have heard. I know that this length C, if you square it, is equal to 5. So in particular, C squared is equal to 5. So mark. In particular, C squared is equal to 5, i.e. C square root of 5. So if you wanted to figure out what the length of the side is, here's a way. The remarkable thing is this thing generalizes. So let me draw this picture once again. Let's say I have a square, somewhat like this. So like this, like this, like this, and like that. But now I don't know that the distance from here to here and from here to here is 2 and 1. Let me call them just A and B. So to go from here to here, I go A steps to the right. From here to here, I go B steps down. So similarly, A steps up, B steps to the right, B steps to the left, A steps up, and so on. Question, what is the area of this figure? Well, so B is this distance. Same trick. Area is 4 times the area of such rectangles. I mean, these 4 rectangles, 4 triangles are the same triangle rotated 4 times 90 degrees. So the area is the area of each one of those, AB divided by 2, then multiplied by 4 triangles, and plus the area of this small square, or this area. So the side is B minus A. So here we have A, here we have B, so this thing is B minus A. And let me figure out, well, let me open the brackets, let me simplify this. So it's AB times 2, 1/2 times 4 is 2, plus B squared minus 2 times BA, plus A squared, open the brackets here, plus 2AB and minus 2AB cancel out. So overall it's B squared plus A squared. And also, of course, we have a different way to find out this area. If we do know what the side is, if it is C, then the area is C squared. Just because it is a square. But now we computed the same area. It's the same number. So it must be true that A squared plus B squared is in fact C squared. So conclusion from this, in this picture, A squared plus B squared is in fact equal to C squared. Now, if you heard about Pythagoras theorem, that's exactly Pythagoras theorem. So let me write down Pythagoras theorem. Pythagoras theorem is, well, basically about such a triangle. If you have a triangle with right angle besides A and B, then the other side, satisfies c squared is equal to a squared plus b squared. In a right angle triangle. And then we draw some kind of triangle. Consistent with that picture, that will be A, that will be B, that will be C. C squared is A squared plus B squared. What we did right now, we not only stated this fact, we have an explanation of this fact out of really basic things. Area of square, area of right angle triangle, and some simple subdivision like this. Subdivide the square to 5 parts, 5 very simple parts which is easy to compute the area. So not only now we know the Pythagoras theorem, not only we can compute the length of the third side given the other two sides in the right angle triangle, which is interesting. We also have a really simple explanation. We have what mathematicians call a proof. So a proof. So the proof is right here. Well, here it was just an example. Here is basically the complete proof. I have a right angle triangle. Well, I complete it to such a picture. I compute the area of the whole thing 2 times. One time I get the area in a squared plus b squared. Another time I get that it's c squared. So the two must be equal. A proof in mathematics is basically a sequence of simple logical steps which in the end convinces you that something is true. And here we did just this. I tried to convince you that in this picture, c squared is a squared plus b squared. Now, I mean, I cannot appeal to authority of some textbook or something like this. In mathematics, we derive more complicated things from simpler things. And here are the simple things that I took for granted. So this simple thing, this one, well, that one I actually proved for you. Out of these things, some simple pictures, some calculations, and now I convinced you that c squared is a squared. Okay, so questions about, first of all, Pythagoras theorem, and maybe more importantly, its proof. How many of you have seen a proof of Pythagoras theorem before? How many of you have seen a different proof, a proof which is different from this one? So all the rest have seen exactly the same proof? Okay. All right. Now, why did I mention the Pythagoras theorem and its proof here? Well, it's because in the plane, well, once we introduce coordinates, so x coordinate, y coordinate, 1, 1. You might want to ask questions about distances. We have 2 points, let's say point with coordinates x0, y0, and another point with coordinates x1, y1. And we want to figure out what is the distance. How far is this point from that point? So, now we have a way to figure this out. We'll use Pythagoras theorem. In this picture, we don't see a right angle triangle, but we will draw one. So we'll draw a vertical line from here. We'll draw a horizontal line from here. They're perpendicular to each other. If I want to figure out what this distance is, I can as well figure out what this distance is and that distance, and then use Pythagoras theorem. So this distance is just, well, the horizontal distance between this point and that point, so it's just the difference in the x value. So this distance is x1 minus x0. Similarly, the vertical distance is just, well, the difference in the height of the points, so it is y1 minus y0. So the distance between points x0, y0 and x1, y1 satisfies, let me call it d, the distance. D squared is this thing squared, x1 minus x0 squared, plus y1 minus y0 squared. I.e., the distance is the square root of this thing. So now we have a way to figure out what the distance is between 2 points, if only we know the coordinates of these 2 points. Not a picture, not a measurement with a ruler, just a pair of coordinates, 1 point and for the other point. So let's have a short example. The distance between is, well, we'll just use this formula. We have 2 points, the difference in x values 5 minus 1 squared, the difference in y values 0 minus 2 squared, so it's square root of 4 squared plus 2 squared, which is square root of 16 plus 4, square root of 20. So once again, the beauty of such formulas is it allows you to find some geometrically significant information, distance between 2 points, without using any measurement tools, any pictures, just using simple algebra. Okay, so questions about distance. So the knowledge of how to compute the distance between the points. Let's do another thing. Let's describe circles in the plane. So for now we know a way to describe only one figure on the plane algebraically, that's a line. Now we can also discuss circles. So what is a circle? First of all, you'll recall what a circle is. So if you have a point in the plane and some distance, the point is called usually the center of the circle and the distance is called the radius, then you can try to find all the points whose distance from a given one is equal to this number r. This is center. So what's special about the circle is for any point on the circle, the distance from the point to the center is r. So usually people explain it like this: if you put a stick here and you tie a rope here, you let it go walk around, so it cannot go more than the length of the rope, so if the length of the rope is r, then the grass which will be given lies inside of this circle. Okay, so that's an explanation, kind of completely geometric explanation of what a circle is. It's a set of points with distance from the center is equal to a given number r. Now let's describe the same set of points on the plane where coordinates can be chosen. So now we have coordinate plane. I'll have the center now given not as a point, but rather as a pair of coordinates, x0, y0. And the radius will be some number. It's hard to draw a good circle on the board. Let's pretend that it is one. So my question is, suppose I give you another point on the plane with coordinates x, y. How do I figure out whether it lies in the circle or not? Well, we'll take this trace that the point lies in the circle exactly when the distance from this point to the center is equal to r. And rewrite it algebraically. So a point x, y is on the circle of radius r center at x0, y0. So the point xy is on the circle of radius r center at x0, y0. When the distance d from x0, y0 to xy is equal to r. So for now I just wrote in words the geometric statement that the point lies in a circle when its distance from the center is equal to the radius. But now we know how to translate every word in this sentence into algebraic terms. We know what the distance is. So let me rewrite it in algebraic terms. The distance from this point to that point, well, we have a formula. Square root of square of the difference of x values plus square of the difference of y values. That's the distance, must be equal to r. Well, now we have an equation for this circle. If you know just the coordinates of a point in the plane, x, y, we have a way to check whether it actually lies in this circle. We just plug it into this formula. We don't have to measure anything in the plane. We don't have to estimate the distance. Here's the equation. Usually we write this equation without the square roots. It's just more convenient to write without square roots, so we square both sides. And we write this equation in such a form. X minus x0 squared plus y minus y0 squared is r squared. So if we write down the final result, the equation of the circle radius r center and x0, y0 not squared plus y minus y not squared is r squared. And let's start with a simple example. We'll start with the simplest possible example. What is the equation of a circle with such and such center and such radius? So the equation of a circle radius. She wanted some good numbers. 5 center there. 1, 2 is okay. So this is just a question of using the formula. So the distance, square of distance from x line to 1, 2 is x minus 1 squared plus y minus 2 squared, and I want this to be equal to the radius squared, which is 25. So the most basic thing is you have to know, given the center and the radius, how to write down the equation, or vice versa. If you are given such an equation, you should know that it describes a circle with a given center, 1, 2, and the radius, which is square root of 25. Well, it would be really boring if this was all you could do with an equation of a circle. Just write it down and interpret. It's kind of defeats the purpose of doing algebra and interesting things. So let's do more interesting stuff. So now, not just an example, but rather a problem or exercise. Find all the points by both on this circle, and I mean that circle, the one centered at 1, 2, having radius 5, and the line x plus y is equal to 10. So what we are doing geometrically, we'll have this circle centered at the point 1, 2. Somewhere here is the center. We have a line, s plus y is equal to 10. It has, let me write this line in the form y is equal to 10 minus x, or minus x plus 10. If I want to sketch it, well, it has slope minus 1, y-intercept of 10, so it goes somewhere like this, goes like this. And the question is, first question, does it intersect the circle? If it does it intersect it at 1 point, at 2 points? No, it's 3 points, 5 points. So the picture is kind of not really convincing. I mean, without drawing a really accurate picture, which I cannot draw on board, I can't really know whether it exactly touches this circle, or intersects it at 2 points, intersects it at 0 points, doesn't intersect it. I have no idea. But we'll use algebra instead. So let's do this. So first observation. Suppose I have a point x, y, which lies on both figures, both on the line and the circle. On the algebraic side, it means that this point x comma y satisfies not just one equation, but two equations simultaneously. The equation of the line and the equation of the circle. Just because any point that lies on the line satisfies the equation of the line, any point that lies on the circle satisfies the equation of the circle. If it lies on both, it satisfies both equations. So xy lies on both figures when both equations hold. Both equations hold. And I mean these two equations. One is the equation of the circle, xy minus 1 squared plus y minus 2 squared is equal to 25. The second equation is the equation of the line. Let me write it in this standard form. Y is minus x plus 10. Right? So now I translated the geometric question of trying to intersect the figures into the algebraic question. Find all points x comma y which satisfy these two equations simultaneously. Well, this is always the case that algebraic questions are easier than geometrical ones. Quite often it's the opposite. But this question is simple enough. Right here, well, I have two equations about two unknowns, x and y, but I can simplify them quite easily. I have an expression for y in terms of x. So use or plug y equal to minus x plus 10 into the first equation. We'll get x minus 1 squared plus, instead of y, we'll write minus x plus 10, then minus 2 squared is 25. Now I reduce my equation, my two equations about two unknowns to one equation about one unknown, which is a huge step forward. It's usually much simpler to solve just one equation about one unknown. Now, what kind of equation this one is? Well, I'll simplify it as much as I can. So, first of all, I'll rewrite this as x minus 1 squared plus minus x plus 8 squared is 25. Then I'll open the brackets. So x squared minus 2x plus 1. I'm using the formula that a minus b squared is a squared minus 2ab plus b squared. Plus, so here I have similar thing, 8 minus x squared, so plus 64 minus 16x plus x squared is equal to 25. Now I will rearrange these things a little bit. So x squared, another x squared, a total of 2 x squares, minus 2x and minus 16x, so a total of minus 18x, plus 1 plus 64 plus 65 is 25. Now I start seeing what kind of equation it is. It is a quadratic equation, something times x squared plus something times x plus something else is equal to 0. Well, almost. So I can bring this to the left and make it in this form, where x squared minus 18x is equal to 0. But we simplify it even further. I'll divide by this coefficient 2. So x squared minus 9x plus 20 is equal to 0. And finally, it's a quadratic equation, so I can find its roots. So by completing the square, by guessing, by using the quadratic formula. So whichever way I guess it's not hard to just guess the roots. Let me just recall what the quadratic formula tells. So it's this plus minus square root of this squared minus 4 times f divided by 2. So it is 9 plus minus 1 divided by 2. So it's 4. 81 minus 8. Yes. So let me just recall the formula for solutions of quadratic equation in case you forgot it. Reminder. So if you want to solve a quadratic equation like this, the formula is minus b plus minus square root of b squared minus 4ac divided by 2 times a. Alright, so back to here, we found two possible values for x. It's not quite the points. We just found two x values, but the point is x and y. How do I find the y value? Yes, exactly. So I use the second equation to get rid of y. Now I want the y back. So I'll use it once again to find y. So, as a reminder, now if x is 4, y is minus x plus 10, which is minus 4 plus 10, 6. If x is 5, y is 5, using the same formula. So answer, we have 2 points, 4, 6, x coordinate and y coordinate, and another point, 5, 5. So it's really no wonder that they couldn't easily figure out where they are located. They are pretty close. One of them is 5, 5, is 4, 6, and 5, 5. They're really close to each other. And the algebra doesn't just tell you there are 2 points, it doesn't tell you there are points and they're close to each other. It tells you the exact location of these 2 points. Okay, so questions about this exercise? Yeah.
If you get 4 and 5, how come in the equation of you have negative 9x? Because if you're going to factor that out, wouldn't you get negative 4 and negative 5?
So if I factor this equation out, I get x minus 4 times x minus 5 is equal to 0.
Right.
And then if you want x minus 4 to be equal to 0, it's x minus 4.
Oh, right.
Other questions? Alright, so we start with the new material
just after this class at Math Learning Center. It's at LSK, just down Triple O's and Quarters. So if you want to come, you're more than welcome.